I just found this from an old AP exam. If I were you, the part I would write down would be just that original equation. F of x equals a times e to the negative ax. F of x equals a times e to the negative ax. And that for a greater than 0, okay, whatever, blah, blah, blah. I don't care about that. Find the derivative. Okay, don't look at the choices. See what you think. Remember, a is a constant. X is your variable. See what you think. Is it actually one of the new rules? It's not. But on this particular year's test, this is the closest thing I could come to looking like one of the new rules because I saw the a. But it's not an a to the x, it's an e to the x. It's really just a regular e derivative equation, right? Does it need a product rule? No, because a is just a constant. All right, so thoughts? Tell me what you're thinking. It's probably Joanna's fault. She's not even here. We should have a vote and see if it's her fault. She made us switch to a new test too. That wasn't the one. Oh, I went back to the beginning. Sorry about that. Thanks a lot, Joanna. There we go. All right. Tell me. Now what? What should I do with that a out in front? Leave it. All right. How do I find the derivative of exponential? It is itself. So e to the negative ax. And is that it? Chain rule times the derivative of the exponent. So times what? Negative a. Is that a choice? Which one? Is it e? Okay, so on this particular test, the only one that even looked close was this one, but it really wasn't an a to the x, right? Okay, so I found another test. Number 19. You don't really need to write this one down. What are all horizontal asymptotes? Okay, wait a minute. What do when I see that phrase, horizontal asymptotes, we're just talking about, well, you're thinking horizontal tangent line. Do what? That's vertical asymptotes. Okay, that's where you compare the degree, right? Right? Because really that means it's like the limit at infinity and you're just comparing the degree. But unfortunately, you only can compare the degree if you have like a polynomial over a polynomial. Look at this function. It's not a polynomial. Why did I choose this problem? Because look at what the function is. It's a 2 to the x. Isn't that an a to the x? So this is a problem that uses that type, right? And you're like, yeah, but we didn't talk about horizontal asymptotes, right? We know how to do derivatives and integrals. Actually, this is going to lead us into the next day where it turns out we're going to talk about why we should take the derivative of this. So we will eventually want to do the a to the x rule. I just wanted to show it to you that, hey, there's an a to the x. even though we really don't know how to do this one yet, because we don't know yet that we're supposed to do the derivative. But that's the only one on anywhere on this test that had an a to the x type format. Okay, so all that to tell you, I looked at 3 past tests. I just did a quick look. I thought, while you guys are coming in, I'll do a quick look. I looked at 3 past tests. One of them kind of looked like it was going to, but then it really didn't because it was an E. One of them really does use an a to the x. And then the other one didn't have anything even close to a to the x, just to kind of give you an idea of how often it shows up. Okay? So, ready to talk about our last new set of formulas? Think positive thoughts. Last new set of formulas. Probably of all of them, this might be, one of these might be one we use more than the rest. All right. Let's see. Here we go. You might be thinking to yourself, well, I don't see any a to the x's, right? I don't see any, 3 to the x. I don't see any inverse trig functions. But look in that first integral. Does that look familiar? Wasn't that the derivative of arc sine? I'm looking at this one. That inside, wasn't that the derivative of arc sine? A little nod. Oh, so if we integrate that derivative, doesn't it take us back to arc sine? Does that make sense? I just wrote the derivative formula backwards. And yes, they have a plus c. I'm not going to write the plus c because I don't know why. I'm just not going to. It's there. Okay? What about, I'm going down. What about the next one? Arc tangent of x. And going down, the one we are least likely to see would be arc secant of x. The most likely is this one. And this one, when we start getting into BC topics, this one will come up kind of now and then. Enough that by the time we get to AP exam time, you'll remember it. You'll remember the arctangent one. Okay? Now look to the right. This is the kind of the chain rule version. Do you see how, look at the one in the middle. It's 1 over, instead of x squared plus 1, it says u squared plus a. But isn't a just a constant? So do you see how those are similar? Okay, so if it fits that pattern, it is an arctangent. It would be, the way it comes out to be is 1 over a arc tangent x over a. It's just the formula that we have to know. Okay, so with that in mind, speculate with me on the one down below. Do you see how that kind of looks like the arc secant one? Oh, you know what? I told you something wrong. Arctangent of u over a. Sorry, I was using the wrong variables. Sorry about that. You hear that, Joanna? What if it really blares in her ear? All right, so speculate on the last one. What would you guess? 1 over a arc secant what? U over a. And you would be correct. Now I saved this one for last. Speculate on this one. On the top one. You would speculate 1 over a, but it doesn't have a 1 over a. It's only arc sine of u over a. Why, you ask? Because that's how God made it. I mean, we could go through a proof and you'd see, oh yeah, it doesn't have it. Well, okay, whatever. We don't care about the proof. Okay? So when I look at, remember, those are just the negative ones. Like if there's a negative out, you might say arc cosine, but the way the answer would be written would be like negative arc sine. And so I don't even list those as formulas. I've never even seen those come up on these. Okay? It's really just arc sine and arc tangent that I've ever really seen show up. I think like once in the past 20 years I saw arc secant show up. So I still mention it. But we never really worry about the negative ones to turn into cosine, cosecant, and so on. All right, so look at number 1. The one thing you have to watch out for these is it's kind of tricky because look at how the dx is on top. Isn't that weird? Why'd they put the dx on top? I mean, the way we're used to seeing it is 1 over square root of 4 minus x squared with a dx out at the end. Are those the same thing? Yeah. They just, sometimes if it's just a 1 on top, they tend to just move the dx on top. Same thing. So, which one is this? It's definitely arc what? Arc sine. So I'm going to say arc sine. It's just an x, but it's not a 1, it's a 4. Oh, so what is a? So a is 2. So this would just be the arc sine of what? You could say u, but u is x, right? X over 2. I'm going to write the plus c now, since it's not a formula. Everybody good with that? Well, remember, the formula for arc sine says that you have to have whatever over a. So since this a was not just a 1, but in our case, the a squared was 4, so I know a is 2. Everybody okay? What about number 2? Now, a lot of times people want to go straight to the answer on this. Do you have, it's definitely arctangent, agreed? Agreed? What is a? If I'm comparing it to this, what is a? Is a 3 or is it square root of 2? Remember, here's my formula. 1 over, I'm going to write it like this, a squared plus u squared. So isn't this the u squared and this the a squared? Because the u is what has the variable, correct? So does it make sense that a is square root of 2 on this one? What is the u? 3x? Everybody hanging with me here? Wait a minute. If I'm going to do a u substitution, I have to do the whole u substitution. I have to do the du and the dx. Everybody with me? In order to make this fit the pattern so that u squared is 9x squared, aren't I going to have to let u equal 3x? So if I go through the whole pattern, if u is 3x, whoops, I'm sorry, then du is what? 3 dx. So dx is du over 3. I only wrote down the a so that when I get to the formula, I have it handy. Dx is du over 3. So when I rewrite, I'm going to have the integral of 1 over 2 plus u squared. And it's okay to have the 2 there because I know that's just my a squared, right? And then in place of dx, I have du over 3. So before I integrate, what do you want to do with that 3? Joanna, you can't hear this, but they're saying, and Matthew is squinting. Move the constant, but Matthew came through for us, Joanna. Move the constant out in front. So move the 1/3 out in front, and so I'm really integrating 1 over 2 plus u squared. Now it is primed and ready to integrate, right? Primed to get it, because it's a okay. Kind of a dad joke, wasn't it? All right, so I leave the 1/3. That was already there. If I integrate, I need 1 over a. What would 1 over a be? 1 over square root of 2. And then I would have arc tangent of u over a, u over square root of 2. So to clean it up, 1 over 3 square root of 2, arc tangent, oh wait a minute, what was u again? 3x. So arc tangent of 3x over square root of 2. That would be the absolute most involved arc tangent type 1 you would see.
Before we use substitution thing, can we time that to
Can you do what with the 2? But multiplying by 2 is not going to remove the 2. Because it's a 2 plus, right? And the 2 is not a problem. The 2 is not a problem because that's just my a squared plus whatever. Okay? Look at number 3. So first of all, which of the arc functions are you thinking? Are you thinking any of them? Arc, what'd you say? Secant. Arc secant? I think arc secant, right? X out in front. You're like, oh, it's not an absolute value. It doesn't matter. That just means it didn't matter if it was positive or negative. So let's identify what would be the U and what would be the A. What's the A? What's the A? 3. What's the U? 2x. And since there's a u, we have to go through the u substitution, right? So du equals 2 dx. So dx equals du over 2. So I've got the integral of 1 over x square root of u squared minus 9. And then in place of dx, I have du over 2. All right, I can't integrate if I have both u's and x's. U's cannot be in the same integral with x's. What should I do? Do y'all see what I see? That should be a song. Oh, do you hear what I hear? Dang, so close.
Is that when you set the u equal to the x?
Normally, yeah, we would go back to our u substitution and we would solve for x, right? But do I need to on this one? What is u, you guys? 2x. So couldn't I say this x and this 2 are really like just having a u down there? Isn't u 2x? You with me? Okay, look here. If you're not, Sarah's making a face.
No, it makes sense. I just never would have thought that.
Well, that's why you got me. Now you thought it. Okay. So I'm going to take this 2 and I'm going to say, you know what? I'll just keep it on the bottom. I'm just going to move that 2 right over here. Okay, so now it's a u. So I actually have 1 over u. What you had said, by the way, Callie, going through that, it would have worked. I would have gotten the same thing. This is just a more direct. Okay, u square root of u squared minus 9. Okay, great. Now it fits my arc secant. You're like, there's no absolute value out in front. It's okay. It's still going to fit. So, Luke, you're making a face. Are you okay? Yeah. Okay. I thought it kind of worries me. It makes me think you're like, oh, are you sure that's right? And then it makes me doubt myself. Very insecure sometimes, Luke. Not really. Just trying to make you think I am. I want you to identify, make you think I'm still human. All right. Arc secant. Okay, so out in front is 1 over a. So 1 over what? 3. And then I have arc secant. And then I need u over a, so u over 3. The only thing left is to replace the u back with the 2x. Bam, there it is. The good thing about these on multiple choice, you guys, sometimes if you don't remember the whole formula, you can, if you just know if it's arc secant, arc tangent, arc sine, because usually they'll have like one of each as a choice. And even if you don't remember all the ins and outs, you usually have a pretty good chance of guessing correctly if you just know which arc function it is. Does that make sense? Okay? Wow, it seems like surely we're not done yet, are we? How would I only assign 1 through 13 odd, 21, 23, 25, and 29? That's crazy talk. I'm thinking. Hey, little FYI. Just because we're doing this in the section where we did the new inverse trig integrals doesn't mean they're all inverse trig problems. These could be anything. Any integration we've learned in our entire lives since August. I guess really since like November probably. Okay? So let's work on these now, and then when you get to one where you're stuck, because you will, maybe we talk about it together. How about that? Sound good? Monica, does that sound good to you? Collaborate. Yeah, that's the buzzword. Is that still a buzzword, or is that over now? Collaboration. Yeah. Like, you know, on a resume, you know, one of your skills. I worked in a collaborative environment, blah, 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 blah. That's like, you know, kindergarten. I play well with others. It's so dumb. I hate buzzwords. All right. All right. Oh, I forgot. I have something really important to tell you guys. Look up here. Sorry about that. I'm glad I didn't forget. Oh my goodness, this is going to be huge towards when we get to our quiz in another class or so. All right. What you really need to remember